Good morning, teachers. It was really nice meeting you yesterday. I felt kind of bad that I didn't get to speak more about Arduino and give you a more thorough introduction to what Arduino is all about. So what I decided to do is put together a little video, and I apologize for the low quality production quality of the video. This is a video introduction I made for my students, and it was a while ago, and I've gotten a lot better since then at producing videos for instruction. So I'll add some bells and whistles and maybe some music as well, and then it'll be more interesting, right? All right, so let's do this. So this is an Arduino, and Arduino is an ecosystem of electronic hardware and software, and it enables low-cost, rapid development of electronic devices. So it's ideal for teaching physical computing. And so there's dozens of different Arduino and Arduino compatible devices in the marketplace. But for this course, we're going to focus on this device, which is the Arduino Uno. And it's over a decade old, and it's on its third revision. It hasn't changed much since it was initially introduced. And compared to most computing devices in our lives these days, this is a dinosaur. It's not the most capable piece of equipment. It can't natively connect to the internet. Its CPU operates at 16 megahertz, which is about the same speed as a CPU from the early 90s. And perhaps most shocking of all, it only has 36 kilobytes of onboard memory. And that's about enough memory to store 8 pages of plain text, or about a quarter of a second of an MP3 audio file. So, but it turns out it's perfect for learning physical computing. It can interface with a wide variety of digital and analog sensors, and we can program it to respond to these sensors. It's a single board device, but it has many components, and I'm going to point out some of the most important. So this chip right here, it's an integrated circuit, or IC, is manufactured by a company. Well, it used to be called Atmel, but they were bought recently by a company called Microchip. It's a microcontroller. It's the Atmega 328P. It's the brains of the Uno. It contains a CPU, a central processing unit, where computation is done. It's got a host of peripheral devices built on, such as timers, to accomplish special tasks. And it's also got memory built into it for storing and computing with data. The Uno has a USB port. It's an old AB style connection, and the USB interface is actually controlled by a purposely programmed microcontroller right here. And this is actually the same microcontroller as this microcontroller, but it's in a different package. What else is really important? Reset button right here. Pretty self-explanatory what that does. There's a number of indicator LEDs, one right here which tells you whether power is on. This one right here is actually connected to one of the digital input-output pins on the microcontroller, so you can control this LED. That'll be the very first thing that we do with this microcontroller, with this Uno, is make this thing blink. Then these two LEDs right here, one's for transmitting and receiving, indicate when data is flowing to or from the Arduino from a computer. So what else? Well, there's also a bunch of headers. That's what these black plastic things are called. They're called headers. These are female headers, and this right here these are called male headers. And so these headers are actually, they're ports. You can stick wires in them to make connections directly to the pins on the microcontroller here. So a lot of them up here are connected to digital input-output pins on the microcontroller. These ones down here are connected to pins on the microcontroller that allow you to measure analog signals. And there's a couple pins, a couple ports on the header here for connection. Get this a little closer to 5 volts of power, 3.3 volts of power, or ground. Okay, so this is the hardware we'll be using. Now let's talk a little bit about the software. The program, here's the link, that we'll be using to develop with the Arduino is called the Arduino Integrated Development Environment, or IDE for short. It's a software package that can be installed on almost any computer running Windows or Mac OS X, OS X, or Linux. So the software, it opened up where I was last time. So let me do File. Arduino programs are called sketches. So I do, once the IDE is open and I do File, New, close that out, it opens a brand new sketch window, and it actually gives you the bare bones of what you need in a sketch. You need 2 functions in the sketch, which we'll learn a lot about this semester. One of those functions is called the setup function, and the other is called the loop. And basically, the setup function runs once your microcontroller is powered on, once the Arduino is powered on. So it's a way of initializing the conditions for your program. And then the loop runs, as it sounds like, it runs over and over again, as long as there's power supplied to the microcontroller, to the Arduino Uno. Alright, so this is the basic bare bones skeleton of any sketch that you write in the Arduino IDE. So basically, this software is what we'll use to write programs called sketches, compile them, debug them, and then ultimately deploy them to the Arduino hardware. And so we'll do this for the first time in lab this week. And we'll be working with a program called Blink. The IDE also includes a bunch of libraries and drivers to make all of this stuff possible and allow USB communication between your computer and the Arduino device. And then also, we'll use this a lot, there's a serial monitor, and it's telling me I can't open it right now because there's no connection. Okay. But when you're connected, when you have a USB connection between your Arduino and the computer, a window will open up which allows you to monitor information that's flowing back and forth from your computer to the Arduino and from the Arduino to your computer. And so that's a quick overview of the Arduino Uno hardware and the Arduino IDE, which is where we'll develop programs.